everyone. By request, someone has asked if I can clarify how to calculate horizontal asymptotes. It's sort of, yeah, I can understand how it could be confusing because how horizontal and or oblique asymptotes translate or how they can be identified in a function or a rational function can vary, and it's sort of scattered all over the different sections. So depending on what the question is, how you approach it can be a little different. So I hope this summary will help. The question asked for horizontal asymptotes, but horizontal asymptotes essentially can be synonymous, approximately, okay, synonymous to end behaviors. In other words, as x approaches infinity, or as x approaches negative infinity, in other words, as we go left and right of a Cartesian plane, what does the graph look like? So some examples, let's say you have a parabola. As I move more and more to the left of this graph, the y value continues to go up. So in other words, as x approaches negative infinity, the y will approach infinity. It's like a positive infinity. And on the right side too, as x approaches positive infinity, this graph will continue to go up and up and up. So y is going to approach a positive infinity as well. It's simply asking about the end behavior. The reason why we call it an asymptote is because there are some curves where it seems to approach, for example, a y value of 0, and gets closer and closer to 0, but actually never touches 0. Y approaches a 0, but y will never equal a 0. That's essentially what an end behavior is. So we need to do a little bit of calculation so that we can communicate that part accurately and not just roughly say, oh, it's going to be 0. It's going to be 0. Like, it's not quite accurate. So let me try to get to this and approach this under the, I guess, the umbrella of, well, how does the graph look like at the very ends? First example will be where the denominator is a higher degree. The second example is where the degree of the numerator and denominator are equal. And here's the last example where the numerator has a larger degree than the denominator. Okay, specifically for horizontal asymptotes, for case 1, okay, if the degree in the denominator is smaller, we are going to get a horizontal asymptote of 0. Let me write that better. Y will approach 0. Plus or minus side, we'll figure out how to calculate that later on. Okay. Horizontal asymptote, when the degree is actually equal to each other, the horizontal asymptote will be when y approaches the coefficient of the largest term, largest degree term, over the coefficient of the largest degree term. It's going to approach 2/3. And then for horizontal asymptote of equations where the denominator's degree is the same, there is no such thing as a horizontal asymptote. You will instead have an oblique asymptote. And how that is calculated, we can review very quickly. Okay, so essentially this is not going to equal a 0. This will equal a 0. And this one, we don't even have a horizontal asymptote at all. Let's talk very quickly. For one such as this, essentially what you're going to do is do the same thing as we would do for case number 2. That is, let's factor out, and let's make life easy for ourselves. So let's pretend in our calculations we've done DI and we're on asymptotes, and we haven't done chart yet. Okay. For the horizontal asymptote, we are going to simplify by factoring out as many x's as possible. That's my recommendation. And so x divided by x, it's going to be the same number. And so we can argue that this is possible. We have ourselves 1/2x plus a 5 minus 3/x. This is the same as this. You can argue that. All right. Next, if this function that we just created is the same as that, The reason why that's helpful for us is we can actually plug in x equals approaches infinity, and then as x approaches negative infinity. Let's talk. So if f of x is going to have x approach infinity, that's essentially the same as 1 over 2 times infinity plus a 5 minus 3 over infinity. Of course, 3 over infinity is virtually negligible. 3 over a gigantic number like that is essentially subtracting by a 0. So 2 times infinity plus a 5 minus a 0, that's essentially what the denominator is, which is basically the same as 1 over infinity, which is going to be a 0. We are going to get the same encounter when we get to negative infinity. 2 times a negative infinity, that's just going to be a negative huge number, plus a 5. And in this case, negative 3 over negative infinity, so it's going to be plus a 0. Plus 5 plus a 0 is nothing compared to a negative infinity, so we have this, and so we are going to approach 0. Okay, so this could be like a 0 for the positive side, 0 from the negative side. Anyways, long story short, the y value will approach 0. The y value will approach 0. So on my graph, we're going to it's going to be something like that. My horizontal asymptote is 0. Ta-da! When you have a degree that's equal to each other, I'm going to do the exact same thing. F of x, I'm going to factor out the largest x possible, or largest degree possible. So it's going to be 2 plus 4 over x minus 11 over x squared. You can take some time to work that out and see if you agree with me. Next, this is going to be x squared over 3 minus 9 over x plus 1 over x squared. Again, take some time to see if you agree with me. These two numbers will divide themselves out. And so we have essentially the numerator here and the denominator here. As x approaches negative infinity, as x approaches positive infinity, we will have 2 plus 0 minus a 0 over 3 minus a 0 plus a 0. Essentially, as x approaches negative infinity, it's going to be 2 over 3. Oh, I do apologize. I think I got the signs wrong. I'll say it one more time. If it's 2 plus 4 divided by negative infinity, so it's 4 over negative infinity, it's a subtraction of 0, and that would still be a subtraction. 9 over a negative infinity is a negative fraction. Subtraction, it would be plus infinity plus that. Okay, so there's that. If I do the calculations on this side, I get the same thing. F of x will be 2 over 3 ultimately. So we have for the last part, again, I'm not going to go too much of this, but let's just go to the next part. For the next one, when you don't have a horizontal asymptote, well, I can say you don't have a horizontal asymptote because I automatically know from seeing the numerator's degree being larger than the denominator degree. So first thing you want to do in these kinds of cases is don't try to factor out something. Instead, I recommend you actually divide out, because that is how you will see the end behavior of all things. Here we go. Because this is not a linear binomial, I do need to do long division. And if I want to do long division, well, just like all things, I need to make sure all the degrees are in chronologically decreasing order, or numerically decreasing, whatever is the correct way of describing things. So what do I have to multiply to get to 5x cubed? It would be 5x. So that becomes 5x cubed plus 10x squared plus 5x. Subtract, which gives you negative 10x squared minus 9x. And then I will need a negative 10 to give me negative 10x squared minus 20x. Minus 20. That's a plus 1. I'm sorry, I'm rushing things because, yeah, things are a bit of a rush at home. So this is plus, that's a plus 11x, and plus is a 21. So overall, without even doing any kind of number manipulation, if I do divide my original function, I get 5x minus 10 plus 11x plus 21 all over my divisor. Now, the reason I do this, does that look familiar? It's essentially the same kind of format as what we have here. And so as x approaches infinity, what does that entire bracket approach? It will always approach a 0. That's essentially the whole goal. So as x approaches a really big number, that big remainder that we see here turns into a 0. So you can say that this is going to behave like 5x plus 1 plus a tiny, tiny number, like 0.0000 whatever, okay? And as x approaches negative infinity, same thing. This will be, as assumed or as predicted, a very, very, very small number with negative infinity. And this will still approach a very, 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 very small number. Okay, so there you have it. If the denominator is bigger, the horizontal asymptote is going to be 0 because the denominator will end up as an infinity and the numerator will end up as a constant. So a constant divided by infinity is a 0. If the numerator and denominator have the same degree, you will factor out the x value so that you will leave yourself a constant over a constant, which ends up becoming your horizontal asymptote. So it's not a 0, it's a constant over constant. And when the denominator is greater than the degree of the numerator is greater than the degree of the denominator, you do not have a horizontal asymptote at all. Your end behavior ends up being a linear. Of course, I simplify that. If this degree happened to be 2 greater or 3 greater or 4 greater, then it wouldn't be a line. It could be a quadratic, it could be a cubic, it could be a quartic, so on and so forth. We haven't touched that in class, but I did leave a note about it in our worksheet. So please make sure you take a look at that too. Hope this helps, and I will hear from you soon.